Monday. I hope you're enjoying your day off. I promise I have this video for you. I'll send a remind message out as soon as I'm done. So hopefully that is why you're watching this video. So let's go ahead and get started. I'm going to work as quickly as I can. Remember, you can put me on pause. You can rewind me, whatever you need to do. You know, you can't do that in class, but you can do it at home. So let's go ahead and get started. Number one, we're looking for the measure of angle USV. USV is a central angle. Central angles and their arcs have the same measure. So since this is a diameter here, I'm going to take 180 degrees. I'm going to subtract 88. I'm going to get 92 degrees, which is the answer I'm looking for. Number two, more central angles. I'm looking for the measure of an arc this time. RTQ. So starting at R, going through T, ending at Q. So I know I'm going to add some numbers together. This angle is 85, so this arc is 85, and this is 70. I'm missing this measure right here. All I know is that it's the same as this arc that's intercepted by that angle over there because they're marked here as congruent. The first thing I need to do is figure out, well, how can I get some values for those two arcs? And so I know that my entire circle has 360 degrees. So if I add 70 plus 85 plus 105 and then subtract that difference, that sum from 360, that should do it. So this adds up to 260 degrees. So 360 minus 260 is a nice even 100 degrees. And so since these are congruent, I can split the difference. So 100 divided by 2 is 50. So I know that this is 50 and this is 50. So since they're both 50, now I have enough information to figure out what that entire arc is. So I already added some of the numbers, so I don't have to do it again. So I'm just going to take that 260 that I got before, and then I'm going to add the 50 degrees, and we get 310 degrees. Number three, I'm looking for an angle. In order to find this angle, I need to find the arc that it intercepted. So I need to find that missing amount, and I can use these two numbers, add them together, subtract from 360, and that will give me the number I need. So 128 plus 116 is 244. 360 minus 244, sorry about that handwriting, it's going to give us 116 degrees. Now, so far all I know is that that's 116 degrees, but remember, angle equals arc divided by 2. So my angle is going to equal 116 divided by 2, which is 58 degrees. Alright, lots of those answers. Number four, I'm looking for this arc here. I know that this is a diameter. That's useful. I know that this is 40 degrees. So this angle is 40 degrees. This arc has to be 80. And so since we said that this is a diameter here, then this arc from L through M to K has to be 180 degrees. So this part has to be 100 degrees. Alright, that's the answer. If you wanted to get all mathy, 180 minus 80 is 100 degrees. Number five. On number five, similar problem. I know that this arc here is 80, so this arc here must be 100 degrees. And so then this arc is intercepted by this angle, so 100 degrees divided by 2 equals 50. Number six. On number six, there are several different approaches. I think this is the shortest approach. If this is 74 degrees, I can determine that what the measure of this arc is. So if I do 74 degrees times 2, I'm going to get 148 degrees. So this arc here is 148 degrees. So if I take this arc and add them together, so 148 plus 136 going to get 284 degrees. Now, if I subtract that from 360, I get 76 degrees, which is the measure of this arc here. This arc is 76 degrees. So I can use this arc and this arc, add them together, divide by 2, and that'll give me that angle right there. So 58 plus 76, oops, is 130, oops, got my eraser on, is 134. Divide that by 2, we get 67 degrees. So that is the answer we are looking for. Number 7. Well, this is a special case. Notice that this angle here and this angle here, they intersect the same this arc here. So if they intersect the same arc, if this angle is 68, this angle has to also be 68 degrees. But some of you, what you may have done is you may have gone ahead and doubled this, 68 times 2, and gotten 136 for the arc. And then taken half of 136, and then you end up back at 68. Well, that's okay if you did that. Just remember that now you know that if two angles intersect the same arc, then the measures of the angles have to be the same. This is a special case where you have a quadrilateral inscribed in a circle. All 4 vertices have to be on the circle. And if that is the case, then opposite angles are supplementary. So you just do 180 minus 80, and you get 100 degrees. Next page, number 9. So number 9, this is the case where you have a tangents intersecting outside of the circle. And so whenever the angle is outside the circle, then the formula is angle equals arc minus arc over 2. And you're always going to subtract so that you get a positive number. So you subtract the larger and the smaller from the larger. Well, I don't know what this arc is, but I have enough information to figure out what this arc is right here. Okay? So I know that this part right here is 100, and then the whole thing is 360. So if we just do 360 minus 100, that's going to give us 260 degrees. So that means that this arc here is 260 degrees. So now I have the numbers I need to subtract. So we'll do, so angle equals 260 minus 100 divided by 2. And so we will get 160 over 2, which is 80 degrees. So that angle is 80 degrees. Number 10, similar scenario. So we're going to go ahead and subtract so we can figure out what this missing part is right here. So I'm going to go 360 minus 116, and that gives us 244. So that means that this arc right here is 244. So angle equals arc minus arc over 2. And so our angle is going to equal 244 degrees minus 116 degrees over 2. And when you finish the math, you get 128 over 2, which is 64. Number 11. Okay, so I had to take a little pause. So let's do number 11. So now we're changing gears, and we're not dealing with angles, we're dealing with the measures of segments and circles. And so here we have a secant and a tangent. And so remember, the formulas are crucial for these problems. So let me change colors here. So we know that we have an outside or part here that's on the outside, KL, that has to be multiplied times KM. So the way we do it is part times whole equals part squared. That's our little cheat sheet there to help us know what parts to fill in. So remember, the tricky part here is coming up with the whole. The whole is all of it. It's the 8, it's the x, and the 1. Alright? So we're going to have to add those together, and that's going to give us x plus 9. So I always like to do that part first, figure out what my whole is, even over here. I'm going to have x minus 7 plus 4, which is x minus 4. And then that makes it easier if you do that first. So part times whole equals part squared. Remember, it's always two things being multiplied on either side. And since we only have one segment on this side, I have to use it twice. That's why I'm squaring it. So let's go ahead and distribute. So we get 8x plus 72 equals 144. And then this is just going back and forcing you to practice some skills you learned last year. We haven't done a whole lot of algebra in this class. But when you need it, it needs to come instantly. Now, we all fell for this one. It says find LM. We found X. So we need to find LM. So to find LM, we need to substitute the answer we get, 9, add 1, we're going to get 10. So let me erase that. We're going to get 10 for the actual answer. So LM equals 10. All right, number 12. It says find VT, so make sure you're actually answering the question. Don't just find X, find VT. So again, it's part times whole equals part squared. So part times whole equals part squared. And as I was walking around helping you guys, I noticed that you guys were writing those formulas down. I love it. I was so proud of you for doing that because it really is helpful when you do that. So we end up with 4x minus 16 equals 36. We're going to add 16 to both sides. And some of you probably need to beef up on your algebra skills a little bit. If you want to come see me for some help, just let me know. Alright. Dividing both sides by 4. X equals 12, but that's not VT. VT is going to be equal to x minus 7 plus 4. So it is 12 minus 7 plus 4. 12 minus 7 is 5. 5 plus 4 is 9. Alright, let me move these things out of the way. Okay, number 13. On number 13, we need to solve for x. So it says it there, solve for x. That's all we have to do. And so we want to write an equation that will allow us to find the value of x. So when I see this arc and this arc here, I see that they are the arcs that are formed by that diameter. So that means I can add them together and get 144. So we have x plus 44. Check out this shortcut or different way of doing things. I'm just combining vertically, so I get 2x plus 188. So now I can write my equation. 2x plus 188 equals 180. So you're going to get a negative number here. We're just solving for x. Alright, you can always plug it in and make sure it works. Sometimes people feel a little weird about getting a negative value of x. So just test it and make sure that it works. Alright. Let's look at number 14. Move these a little bit more. Okay, so number 14, what gets a lot of people about this is for a lot of the problems you feel like you should use every number that's there. That's not always the case. The 60, the 105, they are extra. Right. all we need is this part right here. That's a central angle. A central angle and its arc have the same measure. So all you have to do is 7x plus 8 equals 50. Subtract 8. 7x equals 42. Divide by 7. So x equals 6. Number 15. Alright, so this is a case where we have as angle whose vertex is on the circle, so the equation is the same. Angle equals arc over 2. So I know that the angle is 85 degrees. The arc is 27x plus 8 over 2. Some people write this formula as 2 times the angle equals the arc. So anyway, what I was telling you was we could double this angle here and get 150, and then that would be that arc, and then we could use that and subtract that from 360. All right, and we could set it equal to 53x minus 2. That's one way. All right, so 360 minus 150 is 210. And so then I can say 53x minus 2 equals 210. And then from there, I can just go ahead and do the work. So add 2 both sides. Divide both sides by 53. And I'm going to get x equals to 4. Okay, I think that's everything on that page. Another approach for this problem would have been to subtract 75 from 180, because this is 180 degrees. And then that would have given me 105 for this angle right there. And then I could have doubled that to get 210. So either way, it's just an extra step. Alrighty. Let's look at number 17. Almost done here. Number 17. Notice the vertex is inside the circle, not outside the circle. That means we're going to add the arc. So angle equals arc plus arc divided by 2. So this 16x minus 5 is the angle measure. I know it doesn't look like it. It's hard to get it in there. So 16x minus 5 equals 80 plus 70 over 2. So 16x minus 5 equals 75. When you divide, when you add 80 and 70 and divide by 2, you get 75. Just pick up the calculator, do the math. If you're trying to figure out where a number comes from, look at the step above it and check out the math that was done there. 16x equals 80. Divide both sides by 16, and x equals 5. Number 18, same scenario. So the angle equals arc plus arc divided by 2. So I'm going to multiply both sides by 2 and then combine my like terms. So I'm going to get 216 equals, now 6x plus 17x is going to give me 23x. Negative 4 plus 13 is 9. Subtract 9 from both sides. Leaves us with 207 equals 23x. Divide both sides by 23. And so x equals 6. Number 19. On number 19, we have not angles here, but we have segments. So I want to make sure we match up the right parts. So you may want to draw circles or whatever around the parts you need to match up. So for this problem, what we're going to do is part times part equals part times part. So we have 2x plus 2 times x equals 14 times 8. So that gives us 2x squared plus 2x equals 112. So this is a quadratic. We want to make it equal 0. And so it's going to be 2x squared plus 2x. I'm going to subtract 112 from both sides. And then I'm going to divide 2 out of all this so that I have removed my common factors. And I'm ending up with x squared plus x minus 56. Alright, now, clearly that's not the answer. Let's go back and recap what I did. So it's part times part equals part times part. I distributed the x. I got 2x squared plus 2x equals 112. I subtracted 112 from both sides, and I ended up with this quadratic after I divided everything through by 2. So you may or may not remember factoring. And we'll probably need to do a little mini lesson on that. But if you remember, you may have learned the X method or the box method. So we're looking for numbers that multiply to make 56, but add or subtract to make 1, a positive 1. And so it turns out that if they have -7 and +8, that will work. That gives us x minus 7 times x plus 8 equals 0. And then I set each factor equal to 0. So x minus 7 equals 0. X plus 8 equals 0. Add 7 to both sides. X equals 7. Subtract 8 from both sides. X equals -8. And then really in these problems, you want to test to see which answer actually works. And so since this segment right here is x, x can't be a negative number, so the only answer that really works here is 7. Number 20, same scenario. So we're going to have outside times whole equals outside times, oh, I'm sorry, I just said it wrong. Part times part equals part times part, like a robot sometimes. And these parts go together. So I have 15 times x plus 2 equals 12 times x plus 4. I try to color code them. I'm not always good at doing that. So when I distribute, I end up with 15x plus 30 equals 12x plus 48. And then just do my math. I want to group all my like terms together on one side. So I'm going to subtract 12x from both sides. Didn't have to start there. That's just where I started. 3x plus 30 equals 48. I'm going to subtract 30 from both sides. 3x equals 18. Divide by 3. X equals 6. Number 21. Okay, this is part times whole equals part times whole. So remember the whole here. Let me erase this and write this over here. Part times whole equals part times whole. So the whole here is x plus 8. The whole here is 17 plus 7, which equals 24. So it's 8 times x plus 8 equals 7 times 24. So we end up with 8x plus 64 equals 168. We're going to subtract 64 from both sides. We end up with 8x equals 104. Divide both sides by 8. And x is going to equal 13. Number 21, same thing.
The following teachers please report to Lane Thomas's office: Kathy Eccles, Michelle Martin, Dante Williams, Niles Davis, and Jason Turner. Please report to Lane Thomas's office.
So, I'm sorry, we had a little interruption just now from the announcements. So this still is part times whole equals part times whole. So it's going to be x times x plus 17 equals 9 times 30. So here's another problem we're going to have to factor. So we're going to end up with x squared plus 17x equals 270. We're going to subtract the 270 from both sides. We'll end up with x squared plus 17x minus 270 equals 0. And then I'm going to factor that. It's going to end up being x plus 27 times x minus 10 equals 0. So x is going to equal negative 27, or x will equal positive 10. And the positive 10 is the only one that's going to work in this case because we cannot have a negative number for distance there. Alright, almost done. Number 23 here. This is part equals part. Right, so we'll have 3x plus 2 equals 2x plus 9. We're going to subtract 2x from both sides. Get x plus 2 equals 9. Subtract 2 from both sides. X equals 7. Same problem here. 2x minus 11 equals x plus 1. Subtract x from both sides. X minus 11 equals 1. Add 11 to both sides. X equals 12. Number 25. Now, this is a case where you have a radius and a tangent that intersect at the point of tangency. That always makes a right angle. So we'll have a squared plus b squared equals c squared. So this is the c right here. That's the hypotenuse. This is a b. It doesn't matter which one you call a and b. So 10 squared plus x squared equals x plus 9 squared. So we will get 100 plus x squared. And remember, x plus 9 squared, this is kind of on the side. No, I don't like that. X plus 9 squared means x plus 9 times x plus 9. That's going to be x squared plus 9x plus 9x plus 81. Or x squared plus 18x plus 81. So x squared plus 18x plus 81. We can cancel out these x squared. They both fall out since they're the same on both sides. And so we'll end up with 100 equals 18x plus 81. We're going to subtract 81. I think I made a mistake. I just saw my mistake. I changed this 5 to 9. So I wrote the problem wrong, and so it changes all my work, guys. I'm sorry. So I'm going to stop it, erase, and then pick it back. Okay, so when I was doing number 25, I wrote this x plus 5 as x plus 9, and it changed my whole problem. So I found my mistake, so I edited that part out of the video, so I'm starting over. So this is a squared plus b squared equals c squared, and I know that because I have a radius intersecting a tangent at the point of tangency, so that creates a right angle. So I have the Pythagorean theorem in play here. So I'm going to use a squared plus b squared equals c squared. Now, when I go to do this part here, I'm going to have x squared plus 10 squared equals x plus 5 squared. And so x plus 5 squared, you have to multiply that out twice. And when you do that, you're going to get x squared plus 5x plus 5x plus 25, x squared plus 10x plus 25. So this is going to be x squared plus 100 equals x squared plus 10x plus 25. The x squares fall out. So 100 equals 10x plus 25. I'm going to subtract 25 from both sides. I get 75 equals 10x. Divide both sides by 10. So then x equals 7.5. And then the very last one, same scenario. The hypotenuse is x plus 6. I'm just going to go ahead and do the x plus 6 squared now. Now there's a shortcut for this. If you want to know the shortcut, ask me about it. Alright. So now we're going to have x squared plus 12 squared equals x squared plus 12x plus 36. X squares fall out, so I end up with 144 equals 12x plus 36. Let's subtract 36 from both sides. And I'll end up with 108 equals 12x. Divide both sides by 12. And x equals 9. Whew. Okay, well, that was a lot of work. Hope everything goes well with your studying. And remember, you can send me a question over Remind. See you on Tuesday.